Okay, we are going to be talking about transformations of parent functions, kind of combined with inverses here, okay? So, let's get into this. Start with some quotes. Just a reminder, in case your mind is playing tricks on you today, you matter, you're important, you're loved, and your presence on this earth makes a difference whether you see it or not. Another one, you're not a burden if you're sad quite often. You're not a burden if you're living with constant anxiety. You're not a burden if you need a lot of reassurance, and you're not a burden if you reach out for help. Love yourself more. Okay, the day I made the PowerPoint for this, I actually had you guys in class, and I don't know if you guys realized how I was having a terrible day. Like, my anxiety was through the roof. I was stressed beyond belief. Like, I went home and had a complete breakdown. And I'm not telling you this to make you feel bad for me. I'm just telling you this because I know that you guys have days like this also. And I know that just being a human on this earth is really, really hard sometimes. And I think we need to give ourselves the benefit of the doubt. And so when I get sad, I've done this since I was in high school. I look up quotes, and quotes always make me feel a little bit better. And talking about it, I journaled a lot. I went home and I talked to my boyfriend about all this. And it is important to talk to people, and it is important, even if that person is yourself, go look at yourself in the mirror and talk to yourself. I do that all the time too. Anyways, I just wanted to talk about mental health is important. I know I haven't been talking about it as much lately, but it's a constant thing, and there's ups and downs. It's like a roller coaster. Like, some days you're going to feel really high and great, and other days are really low. And it's important to remember during those low days that you are loved. And I know that being on earth is hard. I know that just being a human in general is hard. So anyways, that's my soapbox. Let's actually do some math. So let's talk about some parent functions. So the linear function, f of x equals x. This is just a line, and I think we know this one pretty well. But if you have like mx plus b, you can graph this by like, this is our m, and this would be our b, which b is the y-intercept. So like down here at -4 is where I cross, and then my slope is 2/3. So that means I'm going to go up 2. So this is the up 2 part, and I'm going to go to the right 3. Right 3. And then it just keeps doing that, up 2, right 3, up 2, right 3. And if it was a negative slope, instead of going up, you would just go down. Okay, I think we get that pretty well. Absolute value. So the absolute value makes everything positive. So really what happened here is we had a line that just went like this. It's straight, not curvy like I made it. But then all of this stuff in this bottom corner, well, the absolute value makes everything positive, so it flipped it up here. Okay, so then you can do a table, and I'm going to do tables for all of these, but like the absolute value of -3 is 3. And so like we could plot these points. So like -3, 3 is right there, -2, 2, -1, 1, 0, 0, 1, 1, 2, 2, 3, 3. If you don't know how to graph something, always just start plotting points, okay? You can plug points in and see what you get off. Okay? Easy peasy. X squared. So the x squared graph, I did this by plotting points. We've worked a lot with this graph also, but notice over here. So we go like 0, and then we have 1 and 1, and then 4 and 4 because 2 squared, and then 9 and 9. So this pattern of 0, 1, 4, 9 is always there unless we compress it or stretch it. Okay, because 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, and this just keeps expanding that way. So like if we wanted to, we could plot these points 0, 0, -1, 1, 1, 1, 2, 1, 2, 3, 4, -2, 4, and then 3, 9, and -3, 9. Okay, and there's those points. And if you moved this, so say, we'll talk about that in a second. But anyways, so that's the x squared graph. But then what about, easy peasy, the inverse of x squared? Well, the inverse of x squared, if we restrict the domain, is the square root. And if we want to find the inverse just based on the graph, you can always just switch your x and your y points. So I'm just going to switch them, okay? So that means I have 9, -3, 4, -1, 1, -1, 0, 0, 1, 1, 4, 2, 9, 3. But. Okay, so if I plugged in 9 here, well, the square root of 9, if I was solving an equation, I could get plus or minus 3, but I'm just evaluating this. So I just get positive 3. There's no way to get that -3 out of there, which means that I am going to ignore all of those negative values. Which is why these two things are only inverses if you restrict the domain. X would have to be greater than or equal to 0 here. So that is the inverse of just this piece of it. Okay. And again, we could just plot those points, and I was just switching them. So see, like 0, 0 became 0, 0, obviously. Same thing with 1, 1. That one's easy. But then 2, 4 became 4, 2, and 3, 9 became 9, 3. So we have like 0, 0, 1, 1, 4, 2, 9, 3. Oh, wait, wrong one, 9, 3. Okay. Hopefully that makes sense. So the cubic function, if we look at our table, when you cube a negative, it actually stays a negative. So like if I was to cube -1, well, that's -1 times -1 times -1, which -1 times -1 is +1. So 1 times -1, which equals -1. Okay. So then 2 squared is 8, 2 cubed is 8, 3 cubed is 27, blah, blah. Easy peasy lemon squeezy, hopefully. So the inverse of this is the cube root function, which I am just going to switch my x and my y values. Okay. So it's going to be -27, -3, -8, -2, -1, -1, 0, 0, 1, 1, 8, 2, 27, 3. That's the way that if you know how to graph the cubic, you know how to graph the cube root. Same thing with the square root and the squared function. Okay, so let's get through some transformations. And you've probably seen this chart before, I'm hoping. But let's just go through a couple of these things. I'll just point them to them. So a negative sign right here, and I would write this down. I don't have it on my other slides. I should have, but I don't. So a negative sign is a reflection about the x-axis. If the negative is on the outside of our parent function. Okay. A value here is a vertical stretch or compression. If it is greater than 1, it's a stretch. If it's between 0 and 1, it's a compression. And vertical, this goes with the y values. Okay, because the y values are the ones that go up and down. Those are our vertical values. Okay, f is our function that must pass the vertical line test. We know that. That negative sign there, if there's a negative on the inside, that's a reflection about the y-axis. Okay, so that means your x values become negative. The b, that is a horizontal stretch or compression, and you always flip it. Okay, you always flip this. That's your horizontal stretch or compression. So like say you had, let's have f of x equals 1/2 x squared minus 1 or something. This 1/2 would be a horizontal stretch by 2 because you flip it, okay? Whereas if you had like f of x equals 3x squared, well, then this would be a horizontal compression by 1/3. Okay, you flip it. Anything like inside the parentheses, you flip. H here, H or x. X is our x coordinate. We know that. H is our shifts left and right. And it is always opposite of what you think. I hope you're writing this down. Again, this is not on the other page. Okay, and then K, our final thing, is our vertical stretch. And this is up or down, exactly what you think it's going to do. Okay, take a picture, write this down, something so that you can reference this. Okay, and we're just going to do 2 examples here. But we want to describe the necessary transformations, and then we want to graph this. Okay, so if I have x squared, and g of x is negative 1/2 x plus 3 squared minus 2. Well, our parent function is x squared, so there's my parent function. Okay, that negative on the outside is a reflection across the x-axis, which if I'm reflecting across the x-axis, that means I'm reflecting over this line right here. So all of this is going to go down here, which means my x values go from positive to negative. So I can just negate, or not my x values, sorry. My y values are going from positive to negative. So I can negate all of my y values. So that becomes negative 9, negative 4, negative 1, 0, negative 1, negative 4, negative 9. So it looks like that. Okay, the blue graph is the transformations being applied. Now that 1/2 on the outside is a vertical compressed by 1/2. So if you think about compressing something, think like putting something into a machine. And if we put our function into a machine and from our top and bottom, so say that like your hands or the machine is like right here, and we're pushing in. This is just going to get wider, right? This is going to go out. Whereas if we were stretching it, then we'd be pulling it up this way. It would get skinnier, okay? So if we compress something, it gets wider. So that means I am going to multiply all of my y values by 1/2, okay? So that becomes negative 4.5, negative 2, negative 0.5, 0, negative 0.5, negative 2, negative 4.5. So watch that blue graph right now. See how it gets a little bit bigger? Okay, so that's just we compressed it by 1/2. Now that plus 3 is going to move it left 3, which means I can just take my x values and subtract 3 from them. Or I could just move that vertex left 3 right there. Okay, and then that minus 2 is going to move it down 2, which means I can subtract 2 from all my y values. Or I could just move this down 2 right there. So there is my new function. Cool. Let's do one more. It's really nice. Okay, this one. So x cubed, and we have negative 1/2 x minus 2, and that's all in parentheses cubed plus 1. So first, there's my function with my table of values. That negative reflects across the y-axis. So if I'm reflecting across the y-axis, I'm reflecting across this right here, which means I'm going to make all of my x values negative, or I'm going to negate them. So some might become positive, but so that is negate all my x values, and we get that. Okay. Now that 1/2 is a horizontal stretch by 2. Remember, you always flip it when it's horizontal. Horizontal is our x values, so we're going to multiply all the x values by 2. So I get 6, 4, 2, 0, negative 2, negative 4, negative 6. So we end up with that. So you watch how that got, I was stretching it horizontally. So that means I'm pulling it out this way and this way, which means I'm just going to make it wider. Okay, if you stretch it horizontally, that's the same as compressing it vertically. So I'm going to make this wider, and I get that. Minus 2, that's going to move it right 2. It's inside the parentheses, so it's opposite of what we think. So we're going to add 2 to the x values, and I get that, or you just move your vertex 2. Plus 1 moves it up 1, add 1 to the y values, and we get that right there. Okay, you're going to need to be able to do this. And with this, now you should be able to verify functions are inverses by graphing them using these transformations. And if you ever get stuck on a graph, just plot points. Okay, just start plotting points and you can always graph it that way. Okay, thanks guys. You're super awesome. I love being your teacher. So anyways, yes. Okay, bye.